Well, hello YouTube, it's time to talk about these lines in detail. Before we do that, remember when we were installing CodeBlock, we stated two folders that we are going to use them, like debug and release. So where exactly this source code is, because this is just a file, where folders reside. So see this thing, see tutorial or whatever the name is on your side, right click on it, properties, and there you go, project base path. So we are just going to copy that path into File Explorer or whatever you have, right? And there you go. There is a couple of things here, like a main. This is a project, okay? Just generic outline project. Actual source file is this, C tutorial, C source, C file, and two folders. Obviously, they are not debug and release. Debug and release folders are inside, in bin. But what is in OBG? In OBG, we do have O file. Never edit O file when your project is compiled, when application is already done, because you're gonna mess things up, probably. So just leave those O files. Don't touch them. They are needed for compilation process, because if you open it, it is just some kind of gibberish. Okay, so this is hard-coded stuff. Never change it. We don't care about that at the moment. So what we do care is bin folder. In here there is debug folder, and there you go, main application. This is actual.exe, something that you can double click on it and it will work. Very briefly, if application is small and you are on Windows, but you will see it in DOS. We're gonna try that too, but go to properties and see it is executable, it is application. So yeah, let's run it into DOS. I'm going to say cmd, open DOS, and just grab this main and put it here, because I'm lazy to type things these days. There you go, see my root, full path, bin debug, and main.exe. When I press enter, there you go, we do have results on the screen. Multiple times we can call it, no changes are made, so we got same result. If you're wondering how to get previous line without typing, just press up and enter, up and enter. This is DOS, very simple stuff. CLS, job done. So this is actual application, right? Okay, let me see. We don't need this anymore. Well, can we get those folders in like CodeBlock? Yes, you can click on main and open project folder in File Explorer, and you're gonna have that same thing right here. So obg debug.o, if you remember, bin debug main.exe. But most of the time you are not going to use this if your scripts, programs are small. So you can just right click and get location of it if you're lazy like me. So much about physical thingies. Well, question is, what is this line anyway? What include means? Why do we have hash here and not something else? So in C, this is a way how to grab additional stuff that are written by other programmers. So we can use bunch of .h, which means header files, and we have functionalities additional in them. So we are using them if we need them down there in main or some other custom functions we write. So with this line, you're actually stating, get me all that is in stdio.h, and this means standard input output header file or library. There is a bunch of .h libraries, or in Python terminology modules, whatever. They are external files. How I know that they are actually external files? Well, of course, .h is extension, but you can double click on it and open include file stdio.h. So right click on it, select it, right click on it, and there you go. This bunch of text, bunch of code is written by other programmers, masters of this C programming language, and they are giving us options to have input output functionalities. So this is that file, and bottom line that you're going to take from this lesson, tutorial, whatever is, in code block, right click on something that you have at the top and you will get location of it. You're going to read it. Include, every time when you're grabbing stuff, additional stuff, you're gonna have include with hash and not something else. So if you have 10 of these header files for different purposes, you're just going to have them like this. Of course, the names will be different of those header files, but include will always be on the left side with a hash. If you don't have a hash, the thing will not work. So let's just delete this hash and we are going to compile things. Problem. Expected, all these things down there. Just remember to have hash here. In Python, for example, we are going to state here import. In some other languages, some other terms like using or I include, I don't know. But in C we are using include. Okay, so always you must have hash and include. Well, question is, why do we need those arrows here? Because this is actually how you differentiate between white spaces. This is how you are targeting that file and not something else on the left of S and on the right of H. Because if you don't have these arrows and you try to compile this thing, again we are going to have problem here on line 1. Code block is telling us that we do have an error. Include expects, we do have include, but include expects file name, this file or any other, with double quotes at the side or arrows at the side. So yes, you can use double quotes here and this thing will work, but for default stuff we are going to use arrows with the files that arrive with code block. Okay, there you go. How many of these lines you can have like same? Can you have 3 of them? If we compile stuff, everything will work, but there is no point in having multiple includes of same file. So you're probably wondering, well, what is in this stdio file anyway? Let me find that on internet. This is some old documentation but valid, from 97, open group of single Unix specification version 2 blah blah blah. So this is stdio.h, standard buffered input output, and we're going to include it with include this line exactly like we have here. So these things down there are functions, are methods. Better say function when we are talking about C and not Python. So functions that we can use, and one of those functions down there is printf with int on the left side. It's a return type. Don't worry about that, we are going to explain. So this printf demands a bunch of characters to be printed on a screen, individual characters or characters tied together. So if we click on it, we have documentation that said it will be used this function to print formatted output. We set that formatting. This is our custom stuff, custom string, so it will work. So basically, when you're searching for these stdio.h, just type their name on a Google search, and then you're gonna have a bunch of explanations. You don't need to memorize these things. Just browse through a couple of these methods, but you're gonna remember them over time. Don't worry, don't try to memorize these guys. Okay, so much about stdio.h and printf method that we have here. I'm going to move this to another monitor. Well, question is then, can we have multiple empty spaces between inclusion of .h header and our custom code? Yes, we can. Compiler doesn't care. It is just cleaner like this. So what is this main anyway? Every C program must have a main function. That main function is used to put a bunch of code in here between these type of brackets. So either those things will be directly executed or they will call another source that will be executed. But that source code will be outside of main function. we're gonna learn about that too. So anyway, main function, you must have one, and name must be main, because if you turn this to test, like test, the program will fail. Undefined reference to blah blah blah, ld returned one exit status, which means error. Okay, red stuff, error. So every C program must have main function, big function that will call all other things and thingies inside source code. So what is this int? Int is a data type, because C and C++, they are like middle level programming language, and you need to be careful what kind of stuff you are having as a result. For higher languages like Python, you don't care about that, but in C you must say that whatever this function produced as end result, you must specify it. Is it one character? Is it string? Is it integer? Is it something else? So for main, we must have int here, because manually we are stating that we are returning 0. 0 is a number, so integer. We are manually stating that end result will be integer. So will it be 1 or -1 or 0? It's not important. Generally it is integer. So this main demands integer as return type, and we are definitely manually returning 0 to the rest of the world, telling with 0 that everything is fine. 0 means everything is fine. This is ourselves manually stating that, but compiler will complain whatever we do if we type something stupid here. So you don't need basically to have in a simple programs this line. It will work. Okay, let me test that. But it's customary to have it. It is customary to have it. So I'm just going to have it. Okay, return 0. So integer is data type, return type of main general C method. We must have one main. Now, why do we need these brackets for main, for function? Because that's how you're going to recognize function generally in programming. We do need to have this type of brackets, because in here we're going to put a lot of food for our function to work with. So this is like a food for function. Function with operations will grab some stuff here that is inside the bracket, and it will process something, and it will spit results to the rest of the world. So other programs, other functions, other source code can grab those things that we have returned and use something and use it for something. In this case, we don't demand this function to use anything like manually, because this is simple stuff. So we're just having these empty brackets. Okay, so for main, at the moment we don't need any kind of food in here, because down there we have like a simple instructions. So data type, name of main function, these brackets we must have them, and these curly brackets we also must have them, because this is how we are starting our custom code and how we are ending custom code. This is start and this is end, and in between is our gibberish or whatever we are trying to do. Right. So what is this printf? We stated a couple of minutes ago that this is a function that belongs to stdio.h, among other things. With it we are going to print some kind of string. String is just bunch of text, text between these double quotes. So printf will grab everything here and it will spit it out on a screen. In this simple scenario, we need semicolon, because this is how in programming, well, at least in C and C++, you are telling that this is end of instruction. So this is function, do print this on a screen, whatever it is inside the double quotes, and then go to next line. Okay, when you are done with this, go to next line. This is why we need semicolon. When you need to type semicolon, you're going to figure that out over time, but basically leave that thing just to understand a little bit later. It will become your second nature. Basically, you have function, you give it to food, and then you terminate like instruction and go to next line. So what's the issue here? Well, when you say build and run, you're going to have these two things concatenated. Okay, two individual instructions, but they are concatenated. See, hack the planet. Uh, when you're working with C, you must be precise, like when you want to go to next line. So how to achieve that in a C? Two ways actually. So a little bit of space here, or you don't need space, and then say n, this type of slash, a slash n, and now this will become a vertical difference, vertical space. So save and build and run, and there you go. Hack the planet, hack the planet. Okay, how many times you can have like slash n going to new line? It's up to you. Slash n, slash n, slash n. It's up to you. Save, build and run, and there you go. Big vertical difference. Question is, well, can you have that slash n on individual dedicated line? Sure, we can say print f, and then inside, again, because this is a string, slash n. And now this will be printed, and then white difference will be printed on the screen, and then hack the planet 2 again. So this will work. Okay. Oh, semicolon. Yeah, end of instruction, dedicated one. There you go. There you go. Right. So you probably got this. Yeah, return 0. If you type something else here, like blah blah blah, actually I need smaller number, you're going to see that on a screen. Okay, but this is us manually telling, print this on a screen as a return, as an end result, as a confirmation. See, process returned 5, 6, 5, 4, 6, blah blah blah. If you say 0, it will return 0. But compiler will complain if we have some actual error. This is us manually telling that everything is fine, but if compiler detects that there is a problem, no matter what we type here as a return, it will complain. Can we have negatives here, like negative 10? Sure, we can have that. Yeah, negative 10. Can we have something stupid like negative 0? Let me test that. Well, we can have negative 0 at least in source code. Right, so I'm gonna stick with just a 0, and I think that's the end of tutorial, but let me see, am I missing something here? Oh yeah, so remember, two folders, debug and release. Where is release? We don't see it here because all this time we are working in debug mode, like experimenting, but if you are happy with result and you want to sell this like source code to someone else, you can just switch here from debug to release and then press build and compile, and there you go. Now here you have a release folder and there is a main there, and you can check that in a file explorer. Where is that thing? Just a second. Right, bin, release, and there you go. This is like final version. Of course, it's application.exe. So because we are experimenting, I'm going to go back to source code and switch to debug. Let me test that one more time, and that's it. So let's recapitulate how to say this in English. We're gonna grab stuff from external world. In this case, standard input output. We need it because we are using from it printf method that will spit stuff on a screen. We don't need to have any main method. Main method must have some kind of return type. Because we are returning 0, this method is demanding 0, so it is integer as a return type, as a type of end result. This is individual instruction. We need to terminate it with semicolon. This is how you go to next line, because in C you don't go to next line like automatically, at least when you're using this function. And you can have a lot of white spaces here, like vertically. C, like source code doesn't care, compiler will compile, but it's easier to have, it's more beautiful to have fixed source code, like beautiful source code. So let me compile that, and there you go. It's kind of ugly, but it will work. So let me go to like normal situation, and I'm gonna test it one more time. There you go. It works. So I think it's enough for one tutorial. Oh man, it's more than enough. Anyway, in the next one we are going to talk about, let me see, variables and data types and funny stuff like that. Right, thanks for watching. Sorry for a little bit longer tutorial, but I think that you grasp here the stuff because it's very important to understand these couple of first lines, and everything else will be easier, I think. Well, thanks for watching. Share this channel with other people. Support me if you can somehow. And yeah, see you in a couple of minutes or maybe tomorrow. Yeah, thank you, and see you next tutorial. Ciao.